let me know. So this is the manual of the mitigation controller that you received from Wood. So it's divided into two different sections. First one is the installation, which you already did, and the second one is the working with the software section, which we are going to go over in a bit more details today. So this is just description of the mitigation controller and what it does. So for the installation, of course, there is a package that you have to download first, in which you have all the function that the mitigation controller use. So just download it. I put all the steps here in the figures. You can click on the figure, of course, and you get like a bigger screen with like higher resolution. So for the installation, we have two ways to install the software. First, if you already have MATLAB, then you can install it directly within MATLAB. That's internal installation. So you can access the mitigation controller within a MATLAB. And the second option is to install it as standalone software, which is like normal software that you would install in your Windows. But of course, if you have a Mac, then you would probably go with the first option to download it within the environment of MATLAB. And this second way, so yeah, so I assume that you already chose one and are able to open the software. So now working with the software, okay, so I will access the mitigation controller directly from the MATLAB. So here, of course, you install the software and then it would appear right here in your app tab here. So you click on it and then you get the user interface. And for now, this is the only interface of the mitigation controller. So you have a couple of buttons here. The first button is, and of course, everything is described in detail in the manual. So the first button is when you load your data, so your spreadsheet in Excel. Second one is the number of simulations, the number of iterations for your Monte Carlo simulation. Of course, the higher the number of iteration, the more accurate your results are going to be. So here, my recommendation for you is to set it as 2000 as your minimum. So if you got the time, it doesn't take a lot of time anyway, but 2000 will be like quite sufficient. And the target, the project duration. So this is your target duration. So the duration that you would like to have your project completed within. So your project, first, of course, if you have a delay, then your actual duration or your estimated duration should be like larger than this number. But then you want to optimize your duration, you want to mitigate your duration, then this number should be lower than the actual duration of your project. So assume that you did the analysis and you get information that your project is going to finish within like 1,600 days, but you have to deliver your project within 1,466 days. So you put 1,466 days, and then you run the mitigation controller so that you mitigate the duration to arrive at this very duration here. Okay? If you have any question, just interrupt me, then I can explain more about everything, but this is something I already went over last time. And this button is where you want to save your results. So we are gonna do like a demonstration for all of these, and then you would run your simulation. So for the data, first thing you have to do is to insert your data. So we already prepared for you a template for the data that you are going, of course, to choose, and we already had in that template, there's already a case that we built for you, so you can start from it if you want, or you can just try the mitigation controller using that case. So how to access this? So in this folder here, the MitC 001 is the folder, it's a package that you download in the first step in the manual, and then you extract it and you get all of these documents. So one of the folders here is called the data, and inside it you will find Excel sheet or spreadsheet called case study. So this is your template, let's say, for your case. So you can copy it or just change the data within it for your own case, of course. So Well, inside this spreadsheet, you have a lot of columns that you need to have data for. For example, you know, the first block, this one is related to the project activities. So first column here is the IDs of activities. Of course, you number them sequentially. Second one is activity description. So what is the description of your activity? Examples are contract date, financial close, design, and so on. And the duration of every activity. Of course, since we are doing stochastic analysis, we don't provide only one duration, but we provide three different durations: the optimistic, the most likely duration, and the pessimistic. So these values are going to be used. If I go back to my previous presentation, to build these distribution function for every activities. So you provide this number here, you provide the most likely number here, and you provide this number here, and the mitigation controller is going to build this distribution for you, and then in every iteration is going to select random duration from this distribution. So you don't have to worry about this. You just provide these three values. How to provide these three values? Of course, from expert or from previous data or whatsoever. Of course, optimistic should be less than the likely, and the likely should be less than pessimistic. So, for example, this one here, you have 865 days, likely 920, and 1040 as pessimistic. So in this example, you have activities. We have activities that we have 0, 0, 0. What does this mean? It means that this activity is already executed. Okay, so we know that this activity is executed, so the duration is 0. No uncertainty. We already did it, and that's it. But in your case, if your project is a new project, so you won't have the case where an activity has 3, 0. So activity should have 3 numbers. Okay. And of course, every activity has a predecessor. So the activity that comes before this activity. So for the design, it comes after activity number 1, which is in this case contract date. So the contract date, okay, so contract start or something. Yeah, of course. So you finalize your contract or something, and then you start your design phase. All right. And for example, you have one activity can have multiple predecessors. So activity 5 is dependent on activities 4 and 2. So you have to complete 4 and you have to complete 2 in order to start executing 5. And you can insert these activities with a comma between them or just with a space. You can define multiple activity as well. So this information here, the predecessors, define the network, define your network. So which activity follows which activity, okay? And something important that you have to make sure that you do is that the last activity, so this is a list of your activities that you obtain for your case, and the last activity should be an end activity. So it's a dummy activity. It only connects the activities that do not have a successor. For example, activity number 37, it's the last activity. We don't have any activity after it. Okay, so we're connected with the end. So the end has a predecessor activity 37, and 34, 30, 32, and so on. So all activities that are on the edge that do not have successors should be connected with the end activity. Okay, maybe now when I run the analysis, I will show you the network and it will be clear for you. So we are done with the activities. Now we have to define the mitigation measures that are available for us in order to reduce the durations of activities. Because the problem here is that our project is delayed and we have to provide some mitigation measures to apply them and to reduce the duration of our project, okay? So you have to have a list of different mitigation measures that are available for you. Again, same thing, mitigation IDs from 1 until the end, and then a description of your mitigation measures. For example, here we have the first measure is we can allocate extra engineering design office personnel because this will speed up one or more activities, okay? And if we speed up activities, then the duration of the project can be also reduced. So we define the different measures that we have, okay? And for every measure, we define 3 different durations: the most likely duration, the minimum duration, and the maximum duration. And this duration, we call it mitigation capacity. It means that if you apply this measure here, then you are going to reduce 52 days from the affected activities. So in other words, this mitigation measure affects activity number 3, okay? So it reduces the duration of activity number 3 by 52 days, or 51 days, or 52 days. It depends, because you have uncertainty here, you have distribution, and then you select a random number. And implement an activity, you have to pay for it. Okay, so every activity must have a cost associated to it, right? Because if you allocate extra engineering design, then you have to pay. Extra engineering personnel, then you have to pay for these personnel, and you have to define the cost for it. Again, minimum cost, most likely cost, and maximum cost. So 3 values. You can decide to go for variation or the same value. For example, you can set the same value here if you don't want to, if you know that your cost is going to be this much. Otherwise, you can allow for variation. Now, we have something called dependency factor that I don't want you to, don't pay attention for it for now. It's not really important for you. So the important piece is that you define 3 durations, 3 costs, and the activity that is affected by this mitigation measure. So if you have a mitigation measure that affects or that reduces the duration of multiple activities, then you can insert multiple activities here in the same way, like 3 and 4, or 3 and 4 and 5. Okay, so this means that if you implement this mitigation measure, you're going to reduce the duration of activity number 3, number 4, and number 5, which are here. Number 3, number 4, and number 5. All right. In our case, I will keep it to 3.
Hello.
Yep.
Yeah. Okay. So I have some question, and also a little clarification. So the numbers under the mitigation duration, those number will decrease the risk or the duration of the activity.
The duration of the activity, they will speed up activity. To give you an example, the first one affects activity number 3. So activity number 3 is here, is the design. The duration of the design can be this number, or this number, or somewhere in between. Okay, so something around 900. So if you execute this mitigation, then you are going to reduce around 52 days. Okay, so instead of 900 days, it's gonna take around 850 maybe. So you speed up this activity. So you reduce its duration. And if you reduce the duration of the activity, then you reduce the duration of the project, right? Is that clear?
Yeah, there's just one thing I think, Omar, is I also had a problem. When you move your mouse, people can't see where you're pointing at. But if you click on a cell, I think then we can see which cell. Yeah, now I can see that you clicked the cell.
Okay. It's good. Thank you for telling me this. So again, I will just explain what I just explained. So if you execute this mitigation activity here, then you are going to reduce around 52 days from activity number 3, which is right here. Activity number 3 is the design activity. It takes around 900 days. So if you implement this measure, then you reduce like around 50 days, and this becomes like 850. So you speed up the design activity in this case by executing a mitigation measure, because you set more people to work on the design, then the duration is going to be less.
So there is no trigger on how do I explain this? So from your explanation, then the duration of the design will be reduced by 50, right? But in the software calculation, why does it do that? Because I was thinking that it will be only triggered when the risk for that activity is happen, right? Or so, for example, if there is no risk for that particular mitigation, will it still be reducing the duration of the activity or not?
Well, we are going to talk about maybe about risk. Risk is, you can think about it as additional resource of delay, but maybe even without risk, maybe your project is already delayed because the activities are taking more than what you expected them to take. Okay, this is kind of, we call it not, we don't call it risk, we call it uncertainty in the duration. Okay. So if the activities are taking more than the expected, which is, for example, this number is expected, assume that this activity took like more than this expected, then your project is gonna be delayed. Okay, so your project is delayed. You have to execute mitigation measures to finish your project within your original duration. I'm not talking about risk. We are talking about uncertainty in the duration of activities.
Yeah, just because I get the impression that maybe the concept of the Monte Carlo simulation is not clear to you, Ranar. Did you ever run a Monte Carlo simulation?
Yeah, I had the experience of running Monte Carlo, but not this complicated, I would say, because in the project management course, I think we had Monte Carlo, but we didn't involve the mitigation. It was only, yeah, the optimistic, likely, and pessimistic thing.
Yeah, and that is so we call that the old-fashioned way of doing it, but it basically means that in that Monte Carlo simulation, and Omar showed you the input screen where you could set the number of simulation runs, and within each simulation run, it draws numbers for each activity duration at random, but given the optimistic, likely, and pessimistic duration. So it will always be in between the optimistic and pessimistic. And it does that for every activity in the project. So within one iteration of the Monte Carlo simulation. And then it could be that in that particular run, it goes for quite a number of pessimistic estimates, because it could be that a number of activities are drawn near to the pessimistic estimates. And then you know that your project will not be on time in that particular iteration. And then the software searches for you for the best combination of mitigation measures to keep you back on track again. And that's the novelty of this software. And that is why what you are used to is on the left-hand side, on the orangey cells, basically. So that's the classical way of doing things. You have all your activities and you define your duration estimates. In this software, you also need to define mitigations that affect certain activities that you have to define. And then within each run, when it doesn't make it on time within that run, it mimics the behavior of the project manager. And that means that it will try to incorporate mitigation measures so that you get back on track. And of course, you will go for the measures that are cheap but have a big effect. Now you can do it manually. That's what the project manager would normally do, but you can also automate it, and that is what this software does. I hope that makes it a little bit clearer what the software does. So Omar already, of course, had the presentation on, and this is...
Probably I will just use this slide just to make it a bit clear for Ranar and for the others. You know, this curve, so this is the output of the old-fashioned Monte Carlo simulation. So you get this S-curve. So for example, this is the duration of your project. It corresponds to 70%, but maybe you get extra delays in your activities. So activities are taking like more time to be executed. And then after a while, when you run again, your Monte Carlo simulation, you are going to have your S-curve shifted to the right. And being shifted to the right means you have extra delay, but you have to push it back to the left. How to push it back to the left? how to reduce the duration of activities? It's by applying mitigation measures. Okay, so your S curve is to the right, but it's bad to be to the right because it reduces the probability. So instead of 70%, we have like 10% here. So you want to push it back to the left by applying mitigation measures. The simplistic way of explaining it. But you really don't have to worry about all of that. So you define your activities and duration predecessors, and then you define your mitigation measures. And these mitigation measures will only be triggered if you have a delay in your project. And the one that will be chosen, not all of them, the one that will be chosen are the most effective ones that target the critical activities for specific iteration. Because in one iteration, you could have activity number 3, 5, and 6 are the critical activities that are causing the delay. Then the software will choose only the mitigation measures that reduce the duration of the critical activities. In another iteration, you could have like activities 20, 23, 25 are the critical activities. Then other mitigation measures are to be chosen. So they will be triggered when you have a delay, but only the effective ones will be selected in specific iteration. Okay, so you define, of course, the cost and the relationship between the mitigation measures and the activities. And of course, sometimes you have some extra source of delay, and we call them here risk events, something you didn't really expect. It's not really related to activities taking longer than expected or whatsoever. It's just additional, once again, just additional source of delay. For example, if you look at these risk item that we already defined for you in this case, preliminary design rejection, including extra scope of works. So for example, you did the design and then you submitted it and then it got rejected. This is something that can happen with some probability, but you are not sure that this is going to happen. Okay, but if it happens, if this occurs, then you are going to have a delay of around 100 days. But if it doesn't happen, then you don't have the delay at all. So you have zeros. So you have a list of possible risk events, okay, that can occur. And if they occur, you have the amount of delay that they will incur. So if this risk event occurs, then it can delay your specific activity, for example, or your project by 96 days, 105 or 119, or something in between here. And a probability of occurrence. So 25% of times this risk is gonna take place. And if it takes place, then it's gonna incur this delay. Okay, that's why you have to define extra parameter here, which is the risk probability. And usually the probability of risks are quite low. So you can expect something in the range of 0.0 something and 0.1 or 0.2, because risk events are usually not really frequent. But you can, of course, have some risk event with high probabilities. That's up to the type of risk event. Okay. And of course, every risk event can affect specific activities. For example, if this risk event occurs, then it's going to affect activity number 3. It's going to delay activity number 3. Maybe you cannot start activity number 3 because of this risk event, right? Or maybe this risk event is going to interrupt activity number 3, so you cannot continue with it for a duration of 100 days, for example, because this risk takes place.
I have a question. Yep. So the number in cell U4, the 190, is that the let's say if you go back to the project file to the left, all the way to the left, is that the likely destination plus is that the pessimistic duration? So let's say that the design pessimistic is 1040. Is then the duration of the risk is it 920 plus the 120? Is that it? Or is it something completely different?
I will give you an example to clarify what how this risk affect the activity. So, for example, risk number 1 has a probability of occurrence of 20%. So let's assume that this risk takes place. Okay, so it occurred, and then probably it's gonna be like 100 because it's gonna pick one random number between the in this range between 96 and 119. Let's say that the duration of this risk is 100. It's gonna affect activity number 3 by 100 additional days. So you go to activity number 3. So the duration of activity number 3, let's assume it's somewhere in between here. So it's 900, and you have the risk of 100. Okay, the risk incurred 100 days of delay. Then it's 900 plus the 100 is 1000. So the duration of the activity will become 1000. Okay, so you pick a random number here for the duration. It can be, for example, 1040. We don't know. It can be this number. And your risk event is 105 or 119. So you sum these two numbers up, and then you have a new duration for the activity. Okay. And this new duration is larger than your previous duration because, of course, risk will incur delay. So duration is going to be larger. Is that clear or not so clear?
Yes, that's good.
Yeah, I can explain it, of course, for another example, if you want. So activity risk event number 2, it has probability of occurrence with 5%. So assume that this risk occurs, then it can incur a delay between 13 days and 15 days. Maybe it's gonna take 15 days, okay, randomly. It affects activity number 4. So activity number 4 is gonna have delay of 15 days because of this risk event. Okay, so you go to 4. Well, you don't go to the mitigation controller will do it for you. Okay, so assume that the duration of activity number 4 is 130, and you have what did we say? 10 days. Okay, we have 15 days from the risk, so it's gonna be 130 and 15, so it's gonna be 145. This is how risk events affect the activities. So they add duration to your activities, okay? And of course, one activity can affect one risk event can affect multiple activities. So you can, for example, insert 3 and 4. So if this risk event takes place, then both activities 3 and 4 will have a delay that's randomly chosen from this range. Okay, pretty much everything about the data. So you have data about activities, data about mitigation measures, and data about the risk event. Of course, if you don't want to include your risk event, then you just remove these numbers. You delete them if you don't have risk, but usually you do have risk. You could also run your simulation without mitigation measures. You can play with it. So yeah. This data is the only required data, but if you just give it this data, then it's not gonna do any mitigation because you didn't give it any mitigation measure. So there is nothing in hand to apply, to execute. Now assume that you are done with this data input. And of course you save it.
I have a question. Is there any practical rule of thumb for the risk event duration or mitigation duration? I mean, is it what is the source of error? Because actually I have tried to use this software last night, and then yeah, there is something issue with duration. I don't really remember it, but if we put too much event duration, like 1000 in this kind of example, yeah, for example, or when the mitigation duration is 1000, although that the activity duration itself is only less than 1000, it could be a problem, right?
Yeah, of course. I totally understand. I mean, for now, we assume that you do things in a logical manner. For example, you don't define the activity, for example, as like 130, and then you apply mitigation measure that reduce 200 days. Then it's gonna be negative. right? And it will show you an error. It will pop an error for you. In the later version of the mitigation controller, we are going to implement this as like error flag. So whenever you insert a number that's larger than the duration of the activity, then it will give you an error. For now, it doesn't give you an error for that. It will allow you to insert whatever number you want, but then when you run the software, you will get the error. So make sure, for example, the numbers here are less than the duration of activity. For example, first mitigation measure affects activity number 3. Okay, so duration is 52 days of the mitigation measure. So 52 days is less than 920, right?
Yeah.
Yeah, because you want to subtract this number from this number. You cannot have a negative value.
Yeah.
Okay, so just play it, like say, just play it logical.
Yeah, because sometimes, I mean, this is a new software, so when error pops up, we don't know how to troubleshoot or find the problem. That's the thing. So
okay, that's why whenever you encounter error, please, I put a form for you, or you just send to me by email what was the cause of the error, so when it happened to you, and how I can replicate your error. So what are the steps that you did in order to get this error, so we can include it in further enhancement of the software. Okay. For now, I assume that you will encounter a lot of such errors, incompatibility, or this negative sign, or whatsoever. So please, whenever you encounter one of them, of course, I will help you to solve it, but report it to me.
Okay, yeah, but just want to make sure again. So the what is it? The most important thing is the thing that under orange row, right?
Here?
Yeah, I mean, if we want to run the software, this is the only stuff that we have to have.
Yeah, right? That's to build your network. That's to build your network and to get your S-curve in the old-fashioned way without mitigation. So you build your network, and then you get the duration of your network, of your project, without any mitigation. Okay?
Because I think, we need also to validate whether we put the thing correctly or not, right? By comparing the result of this software without the mitigation, and also risk by conventional stuff like project, Microsoft project, or Excel. So okay, maybe I will try to
you don't have to remove everything in order to do this comparison, because even when you have the mitigation measures, the software is gonna give you 3 cases. One case is without, one case is with, okay, and the third case, which we are going to see. But you don't have to remove this. So anyway, the software is gonna give you one curve that in which it did not include any mitigation measures. So you can compare it to Microsoft project if you want, and it should be the same. It should be the same. If you follow the same thing, it should be quite similar. Yeah. We're going to see this. But I would like to know if you have any question regarding the data here, the data input, and the relationship between these data. So mitigation measures affect activities, and also risk reduce the duration of activities, and the risk increase the duration of activities. Okay.
Okay.
All right. So I'm gonna save this, and I'm gonna go out of it, and go back to our software. So this software, we already prepared our data. Now we need to import it. So we click on that, and you'll get this indicator that's telling you what's going on. So now it's loading data. So you go to this directory. So again, MitC 000 is the package that you downloaded in the first step of the manual. You go to data, and this is the spreadsheet in which your data is in. You import it. Okay, so it's loading the data now. Please wait. Takes a bit of time. Okay, so successfully loaded, but it's 4 because we did not provide all the information that the mitigation controller needs. We have number of simulation. I told you to set it at 2000. However, just in order to make it a bit quick, we will try with 500 at first, 500 iterations. So the mitigation controller is gonna do 500 times the simulation in order to give us the result. And the target duration, my preference, I would like to finish my project within 1,466 days, because this was the duration in the contract that I signed. So I want to stick with it. That's why I inserted here. However, my actual duration of the project, my project is most likely going to be completed within probably 1,600. So that's why I want to do the mitigation. I want to keep it back to this number. And here you have to save where you want to save your results, which are mainly figures. So, well, you could select within the same package, you could select the result folder here, or you can create your own folder. That's not really important, just destination. And you select it, all right? And now you run your simulation. Of course, you have, if you encounter any problem that you don't want to, well, start from being, you don't want to close your software, then you can just reset everything and then start from the beginning, or just close from here. Now we run the simulation, so it's gonna tell you what's going on here. Now it's doing the simulation. So if you have MATLAB, you can see what's going on, and this is but it's not. Usually it does. Anyway, yeah. So it's gonna tell you what's going on here within every iteration. So if you're interested, then you can have a look what's happening, and if you are converging, if you are doing the optimization in a good way, and so on. But we made sure that you don't have any problem here. Okay. And then the simulation is finished, and it's gonna start giving you the result. So you have multiple results that the software will give, and these figures, which are popping up one by one, are saved in the output folder that you chose. So now, while we wait for them to all appear, so let's go to the result. This is the folder that you chose as destination. Every time you do simulation, you don't lose it. You don't lose your result. So your results are going to be saved in a folder, in a specific folder with the date of today and the time of the simulation. So you can keep track of what you have done before, so you don't lose anything. For example, whatever we are doing here are saved in this very folder. As you can see, the time is 14:35. So you can find your results here. You can find your data as well, some of the data that the software gave in tabular form. You can open with MATLAB this data form. You can have a figure in 2 format. For example, you can open, let's just wait to, okay. Okay, for example, you can open independently. So it's the same figure that the software gives. So let's see it within the MATLAB environment. So this is a pretty basic way of implementing network, but it's quite helpful because that's something also the software gives you. It builds the network for you. So the nodes here are the IDs of your activities. So for example, this is activity number 1, and this is activity number 3. This is activity number 38, which is the end activity. And the numbers on the links are the durations of the activity. For example, activity number, 14. Activity number 14 is connected to activity number 15. Okay, and the duration of activity number 14 is 241 days. Okay, so number on the links are duration of the previous activities, and 209 is the duration of activity number 15. But that's the most likely duration. Okay, it's only the most likely duration, but of course you define range of duration. If you remember, I told you about the end activity. In this case, number 38 is the end activity. It connects all activity that do not have successor. For example, activity number 3 is the last activity on this path, so you connect it with the end. Activity number 15 is the like activity on this path. It's this one here. So you're connected to the end. So you should have final dummy activity that you don't have anything after it. Can you see my mouse moving? Hopefully, yes. Okay, so this is your network, and you get a couple of other
I have
results.
one question.
Yeah.
What does the 0 in a link mean?
Yeah. That's the duration of activity number 1. Duration of activity number 1 is 0. If I go back and I show you the data. Okay, 1 second. So as I said, we have, in my example here, we have some activities that have duration of 0, which means they are already executed, so they don't have duration, but I still wish to include them in my network, so they would appear, but without duration, because we already did them. So there is no uncertainty in duration. Okay. But in your case, I assume that you probably don't have such a case unless you are working on a project that's undergoing. In this case, you would probably have such a case. But if it's a new project, then you will always have numbers.
Okay, thank you.
Right? Okay, of course you can build it with, if you are really curious, you can go to Microsoft project and build your network, and it must be exactly the same thing if you provide the same data. But of course, in a better, well, interface there, of course. Okay, so a couple of results. So I show you this, then we can see this is the most important result. So back to the question of runner. So, this is the S-curve that the mitigation. So it gives you 3 different results, 3 different S-curves. So what do I mean by S-curve here? This is the probability of completing your project at specific time. Just focus on this curve here. This one here, that's the curve that's corresponding to the case without any mitigation. So if you don't want to apply any mitigation, then this is the S-curve of your project. Okay, Renard, so you will always get this curve. If you apply mitigation, if you insert mitigation, and if you don't insert mitigation. So how do you use this curve? So for example, this curve means that the probability of completing your project within 1,550 days is 66%. 66%. The probability of finishing your project within 1,500 days is less than around 10%. That's very low probability. And if you remember, we want to finish our project within 1,466 days. Okay, so if we don't apply any measure for 1,460 days, it's somewhere here. So it has a probability of what? Of 0. It means that if we don't apply any mitigation measure, the probability of finishing the project on time is 0. Okay, so we have to do something about it. So we have to apply mitigation measures so that we increase this probability. And that's what the mitigation controller is doing. So it's mitigation controller is trying to implement only the effective mitigation measures so that the probability at this date, the target date, is increased. So this brings me to this second S-curve that's in black. This curve is given by the mitigation controller after it executes some mitigation measures. Okay, now instead of having a probability of 0, the probability, of course, at 1,460 days, which is the target date, the probability is increased from 0 to around 83%. Now I have a probability of 83% to finish my project at this duration. And that's because of what? Because of the mitigation measures, right? Okay, and we have the third curve, and that's of course only for comparative reason we presented here. This curve is the case when you apply all the mitigation measures. So for example, you tell the software, well, apply all of them. I don't want to optimize. Just do it for me. Apply all of them and let's see the results. So if you apply all of the mitigation measures, you are going to end up with this curve. Okay, See the difference?
Yeah, sorry to interrupt, Omar. Now, if that is the case, does this curve also represent that the risk that we have mentioned is also occur or not?
Yeah, in all curves, the risk they take into account risk. So risk occur with a certain probability. So in every curve of these, there is the risk are included. Of course, not all of them. It depends on the probability of occurrence. For example, in one iteration, risk number 3 and risk number 7 occur. So they are included. Another iteration, risk number 10, 15, and 14 occurred. So they are included. Okay?
Yeah.
With the Monte Carlo simulation. But risk is always included in all of them. Okay?
But what I mean actually is that so the line with this the permanent you say that the software includes all of the mitigation regardless that the risk is happening or not.
Regardless of anything, regardless of the risk and regardless of the durations of activities.
Okay.
Okay, always you tell the software always execute my mitigation measures. I have this 20, for example, mitigation measures. Apply them in every iteration and show me what's happening.
Okay.
Yeah, and we do that because if you don't know, if you are human and you don't know, for example, what mitigation measures to choose, maybe the first trial for you is to just try everything, and then you can see what's going on. So you try everything, you put everything in your basket, in your box, and then you run your software. So you're gonna have this one, right? But that's too bad because if you apply everything, if you execute everything, then of course you are going to pay for everything, and that's a lot of money. But maybe some mitigation measures that you don't really need. So why do you implement them and you pay for them? That's why we have the mitigation controller to apply only the necessary mitigation measures. Is that clear? Runner.
Clear. Sorry.
Yeah. Okay. No problem. So these two are for comparative reasons. So you can see there is this difference between the curve where you apply all of your measures and the curve where you apply only the effective measures, of course, which the mitigation controller does. You can see difference here, and this difference represents additional benefit that you don't need. So it's additional cost. This one is additional cost. This is additional mitigation measures that you implement and you don't need. For example, the probability, now if you go for all mitigation measures, then the probability of finishing your project at this point here, which is 1,418, let's go for this one. Probability of finishing your project at 1,400 days is this much, is 40%. If you go with all mitigation measures, but you actually don't need to finish your project so early. So why would you implement measures to increase this probability at this duration? Keep it at 0, because if you go with the mitigation controller, then probability to finish your project at this duration is 0. But you don't need it. You are only interested in this duration. That's 1,466. And at this duration, the mitigation controller is gonna suddenly increase. It's going to give you exactly the same probability as when you are implementing all of your mitigation measures. So at this point, the mitigation controller is going to give you the same probability, which is 83%, but it's executing many fewer mitigation measures. So you are saving a lot of time, a lot of cost, of course, but you are getting the same results. Okay, that's what we call goal-oriented. So we are focusing on this number. So we just start increasing our probability just before this number. You can see this sudden shift. Well, if you apply all of your measures, then you are going to have higher probabilities at lower durations, which is really unnecessary because you don't need that benefit because you are going to pay for something that you don't need. All right, guys. So this is what you will yeah, of course, you will be interested to get this one here. So now you look, if you are okay with this probability, for example, the probability here is 83%, which is quite high, but probably in your case, you can get low probability like 40%. So you get this point at the target duration, your target duration, and then you get corresponding probability with 40%. What does this mean? If someone wants to answer, so what if you get a low probability here that you are not happy with? So I'm happy with 83%, but if it was 40%, then I'm not happy with. It's still low probability. What would you do in this case? How you increase this probability is by introducing additional measures. This means if the probability is low here, so you use the mitigation controller, but the probability is still low, it's not enough for you, then these measures are not enough. Then you have to extend them. You have to provide new ones. Okay? Because the software implemented that, and then the probability is still low. So one solution is to increase the mitigation measure that you have.
Or by reducing the variability of each activity? Yeah,
but that's something you don't have control over. The variability of activity is something you get from the past. For example, usually when you build I don't know, a floor in a building, it usually take like 100 days or whatsoever, 10 days, but maybe sometimes 6 days, sometimes 13 days. But that's something you cannot control because it can just happen that it takes more days.
Okay.
Okay, so you cannot play with that. The duration uncertainty. What you can play with, what you have control over, is the mitigation measures, the type of mitigation measures, and the quantity of mitigation measures. Yeah.
Yeah.
Okay, so you are providing like mitigation measure, you are providing like solutions to reduce duration of activities. And of course, the risks are something that you don't have control over. Because if you already identified 20 risks, then you have to include all 20 risks. Otherwise, you are not really modeling the real life, because in real life, risk can occur. Okay. Now
yes,
we are done with this.
I still have one question. So let's say you are trying to implement this real time during your project, and maybe some of the mitigations you could not implement because, I don't know, maybe it was just not possible. Does that mean you have to remove it from this mitigation controller?
You have to remove it. If it's not possible to implement, then you don't have to include it in the first place. If you included it and then turned out that this is not possible, it's not feasible for some reason, then it's just not a mitigation measure, and then you have to exclude.
But aren't you doing this before you do your project? This analysis?
You can do this analysis before your project, but on a weekly basis. Okay? Because it happened that things turn out to be different.
Yeah.
For example, at one moment you have this activity. I will just tell you. At one moment you have this activity that you are not sure how long it's gonna take. But when you implement this activity, then you are sure that this activity took you, for example, 900 days. You know, because you executed that. So you update that, and then you run your analysis another time. Okay? Or in this case, 0, 0, 0 probably, because you executed that. Okay? So this can be, the mitigation controller can be used at different stages of your project. In the first stage, before in the design phase, but during implementation, you can have a run on a weekly basis or bi-weekly basis to update your data, because you are already executing activities here. So at one moment it will be outdated. Some activities you don't have any more uncertainty because you executed them, so you have to update and run again.
Okay. Yeah.
Did that answer your question?
Yeah. So let's say during the project, this has done before the project months, and during the project, some of the risks that you have identified did not play out or did not happen. So then you have to update your everything again.
Yeah, you mean if you have a risk that affects activity number 3,
Yeah,
and you executed activity number 3, and this risk didn't happen, then you have to remove this risk and to update the duration of the activity that executed, or just to get rid of it, to remove it, because it's no longer part of your remaining project activities. So you just remove it, or just set it 0, 0, 0, and you remove the corresponding risk.
Okay.
Okay, that's the updating. So of course the software will also do it maybe in Primavera. You have to update in Microsoft project. The software cannot know what's your current status. It's just something you have to do, whatever tool you are using. So it's not like a drawback and mitigation controller or something. It's something that of course you have to do. Okay, so it's project updating and another run of mitigation controller. As you saw, it's quite easy. All right, so now we saw this S-curve, and let me show you some results about the cost, because I told you you execute mitigation measures, but this mitigation measure costs you something. It has a cost. If you want to employ some extra personnel, if you want to get more resources or more material, you have to pay for them, because they will help you to reduce durations. So because the mitigation controller is only going to choose effective measures, only effective measure, so you are going to pay less than when you implement all the mitigation measures, of course. So mitigation control is based on Monte Carlo simulations. In every iteration of the simulation, the software choose a set of mitigation measures, and it will compute the cost for these measures. For example, let's say in the first iteration, you chose these measures, like this one, and this one, like 4, 7, and 10, and then the cost was this, and this, and this. Okay, so this is your cost. Okay, then it's gonna so it will save this cost for this iteration. It's gonna do another iteration and get another cost, another iteration, another cost, and at the end it will give you a distribution of the cost for all iterations. So in one iteration it cost me this much, in one iteration it cost me this much, and so on. Okay, and you draw this distribution. So the mean value here, or the most likely value, is this amount, is like 300,000. So most likely, if you use a mitigation controller, you are going to pay 300,000. If you don't use a mitigation controller, if you implement all mitigation measures in every iteration without optimization, so related to this curve, again, this curve, you are going to pay this much. So it's, you get this number here, so it's 4 million, right? It's 4,400,000, while with the mitigation controller, it's just 300,000. Can you imagine? It's like 12 times more. It's 12 times more. Of course, I'm not saying that a human would execute all mitigation measures, because that would be a stupid human. But even if a human with a human capability try to select the effective measures, they will probably get here. Yeah, with intuition, as with a human way of optimizing, we'll get here. But with the with the mitigation controller, you are sure that you are getting the lowest cost possible while achieving the highest probability possible. So we are getting the same probability as if we're applying the all mitigation measures, but we are paying much lower cost, which is this one here, or this one.
Yeah, so basically, sorry, so the spike between 4 and 5 is basically the sum of the cost of the mitigation that we already established in the Excel, right?
Can you repeat your question?
Yeah. I just wanna make sure that this peak between 4 and 5, the value is basically the peak around 3, between 2.5 and 3 million is just the sum of all mitigation, right? Mitigation cost, I mean.
What do you mean 2.5 and 3 million? We have 4 and 5.
Sorry, the PDF. Sorry, I mean the PDF. Yeah, yeah, 4. So this value 4.4 million, right? Is just the sum of all mitigation that
Okay,
we establish in Excel, right?
Well, one second. You mean this one?
Yeah, that one.
Exactly,
Yeah,
exactly. But why do you have distribution? Because why don't you have just one single value if it's just a sum? Why do you have distribution? Because you have uncertainty here. Okay, you are sure that you are selecting all the measures, but maybe in one iteration, this measure will cost you, this measure will cost you this amount. In another iteration, the same measure is going to cost you this much. So there's uncertainty, okay? But yes, this peak here is related to all mitigation measures, so it's just the sum of all cost for all mitigation measures, okay? But since you account for uncertainty, that's why you get like just a little bit of bound. So it can be this much, but it can be also this much or somewhere in between. Did I answer your question here?
Yes. I just want to make sure my understanding.
Okay. And every point here, it can be the summation. It is the summation of the used mitigation measures only, because the mitigation controller does not choose all of them, and every iteration can choose like a set of them that prove to be effective. Then it's just the summation of their cost, and that's why it's low. Okay, can you understand the difference? All mitigation, just effective mitigation, cost is much lower than if you go for all of them. Okay. Of course, you can get more information if you just read the paper, because in the paper there is the same example, but of course in different wording, then you can get a better understanding if you're still struggling with it. This is just the same thing, but it's cumulative curve. So instead of distribution, you have cumulative curve. So this cumulative curve, it gives us the information that the maximum cost, this point here, when you reach 101, it means the maximum cost that you would pay using the mitigation controller is this much, 1,700,000, while the maximum cost you would pay when implementing all the mitigations are 4,400,000. So this point here, when it reaches 1, corresponds to this point. This point here. Okay? Don't worry about that. It's important just to understand what these curves mean. Other results that the mitigation controller gives, it gives you the criticality. It gives you criticality index for every mitigation measure. So these are our mitigation measures from 1 to 19. We don't have 20, right? 19. So that's why 20 is nothing. From 1 to 19, it gives you the percentage of time every mitigation measure was executed. For example, mitigation measure was executed in 37% of times. Okay, measure number 1 was never executed, was never selected by the mitigation controller because it's not effective, it's not useful. Number 3, this percentage, you have, for example, mitigation number 18, mitigation measure number 18, which is this one here, because maybe it's cheap, but it reduces a good duration from critical activity. That's why it's always being selected with a percentage of around 70% of times. So it gives you more information on which measures are important. So now if you want to make decision, and if you want to really execute, actually you go to your project and you really want to execute measures, then you would choose this one, right? You would choose this one, and then this one, and then this one. You go according to the criticality, because this criticality gives you the importance of this measure, the effectiveness. All right. So this is criticality index related to mitigation measure, but the software also gives you criticality index for the project path, because the project has multiple paths, and you hear about something called the critical path, right? Critical path is the longest path. But since we are doing stochastic analysis and the durations of activity are changing, then the duration of the paths are changing as well. Sometimes one path is the longest, another time is another path is the longest. So we don't have something called critical path, but we can have different potential critical paths. So something can be critical in one iteration and can be not really critical in another iteration. Okay, and mitigation controller identifies this notion of a critical path, multiple critical paths for you. So we have two cases here, without mitigation and with tentative, and this is just like the mitigation controller, of course. You can see tentative means mitigation controller. The two cases, without and with. So without mitigation, you have, for example, this is the ID of the path, so path number 1, path number 2, and so on. Path number 1 was never a critical path. In all iterations, it was never a critical path. So it's not really an important path you had really to focus on. Number 2 was critical in, well, 18% of times without mitigation. With mitigation was critical in 25% of times. So path number 5 was the most critical path because it happened to be 50% of time critical, okay, with mitigation, because we have two different cases. Without mitigation, it's like working on something really, I mean, different network than with mitigation. That's why we have two different results. But just focus on one of them. Let's focus on the gray one. That's with mitigation. So number 5 is the most critical path. Number 15 is almost, well, no, number 2 is the second most critical path, 25%. Okay, and number 11 happened to be a few times critical path, but other paths were never critical. So we have 4 possible critical paths that we have to focus on. But you know, on critical paths, we have also critical activities. So activities also can be critical sometimes and can be non-critical on other times. And this is something that the mitigation control also provides you. So we have the activities here. Okay. And for every activity, it tells you the number of the percentage of times, the percentage of iteration that an activity was on a critical path. So that an activity was a critical activity. Activity number 1 was always critical. It was 100% of times critical because it was on a critical path. Okay, activity number 4 also. Activity number 7 happened to be like around 20% of times critical, but not always. But some activities were never critical at all, were never placed on a critical path. So these are not really critical activities. So you don't really focus on them. You focus on more critical activities, you know, the 400%, and then less, and then less, and then less. Okay, it can just give you like kind of prioritization in your mind. You know, what are the activities that are really critical, not the critical activities that you determine in deterministic approach using, for example, BERT approach or something. Those are, let's say, we call them like fake critical activities because they are misleading. They are telling you that I am critical, but when you do stochastic analysis, they turn out to be not really critical. Okay.
Okay. Sorry, Omar. One question. The previous figure 3. Okay. What is the definition of project path number 15, for example? How can we know what are the activities that builds the path?
Yeah, well, it's not shown here which activities are placed on path number 15. That's information, of course, you can get from MATLAB if you're really interested in. But if you look at the this network, it can be the path number 15 can be this path, for example. I don't know. It's not mentioned here.
Oh, okay.
And all activities that are on the path make this path. So it's just ID for a path, but we don't know which path is that. And this is maybe some improvement that we have to do to show which activities are on which path. But we don't. You cannot see it now unless you go in MATLAB. Then you can see this information if you are interested.
Yeah.
Okay.
Yes, okay. Because I thought that it should be shown in figure 1, but in my memory, I think I don't see that there is the name of each path. So
Yeah.
okay. Okay. So there is a room for improvement.
Yeah.
Okay.
Okay. So I think we went over everything.
I also have a question. When you go to the graph that you just explained, I think it's 4.
Yes.
Yeah, I noticed that activity number 2 is not on the critical path, but it is like if you go to the Excel sheet, it is in the beginning and also in the diagram, it's right.
Yes.
Yeah, why is it not in there? I mean, it's at the beginning of a project and it doesn't take time, but it's not on the critical path.
Okay, that's really good question. Because it's in the beginning of the project, but you could have this path. It's not on the critical path, because probably your critical path can be this one in one iteration and this one in another iteration. So you are not passing through 2.
Okay.
Right? So it's just, it's like just independent activity that occurred in the beginning of the project, and it happened to be already executed because duration is 0.
Okay.
And so you are not going to pass through it. So whatever you do, you're going to start maybe with 1, but never with 2.
All right, thanks.
Okay, this is just the reason for it. So, okay, and also activity 1, although that's really funny because activity number 1 is something that's already executed, that has 0 duration. But I'm telling you that it's critical, and this is really misleading. I'm telling you that it's critical. Why? Because it just happened to be on the critical path. This is the reason why it's critical, but you can do nothing about it because that's something you already implemented. Yeah, to avoid this kind of problem, to have activities that are executed but are still critical, you just have to remove these activities from your project because they are done. Then just get rid of them. Okay, then they will not be shown as activities, and you won't get this case of having critical activities that are already executed. I think we have. All right, so this is pretty much everything. Of course, if you want to do some additional like analysis just to play with it, so just Ruud, are you still with me?
Yeah, I'm still here.
Yeah, just question. Do we have still some time so I can just go over few cases changing the duration of the project?
We have some time, but I think the question also to the students would be if they still have questions or they still have some time for some demonstration from Omar, because I think officially
it will just take a few minutes for me, but it's really important what I'm doing.
Because I would also, before you do that, I would also like to ask the students which groups already have a network planning that they can already play with, not this afternoon, but they have ready for inputting in this software. So Renk, you're nodding yes? No, okay.
Yeah, to be honest, I already have the S curve for my from my contractor of interest, but yeah, it's a very detailed, and then I just try to simplify it.
Yeah, that's a good thing. That what you can do is you could have a higher level planning with like more generic activities. So that's one way of making it less complex. The other thing could be that you just take a part of the whole project, so not the total duration, but you focus on one part of the project where you then apply your simulation to. Because of course for this course it's not necessary that you do the whole planning as you got it, but that you show us that you understand how this works and that you are able to apply it. I think that's very important, because what Omar of course has a very nice and detailed project, but if you have a less detailed project and less mitigations is also fine, but make sure that it makes sense what you're doing and that you can show us how you applied it and that the results are interesting. So, Richie, do you have a network planning that you can use? Did you obtain one?
Do you mean the project file, the MS project file, the planning file?
Yeah.
Yeah, I have that, but I still need to think about the risk and the mitigation.
Yeah. Because, and of course, you can do some assumptions here. In an ideal situation, you ask your project manager of the type of mitigations that he had to apply, or the things that went wrong, and then from that you can basically derive mitigations that were applied. You can also use common sense. You can think of mitigations that would be applicable to your project. So you have some leeway here. Mickey, did you obtain a network planning?
He told us in the last interview that he would think about it, but we mailed him on Monday, I think, but we haven't heard anything yet.
Okay, but you really need that, otherwise you can't finish.
Yeah.
So put the pressure on, I would say. Thijs, did you obtain network planning?
Yeah, on Tuesday we said that was not going so smooth with Dura, but actually after that meeting he sent us an email that he was able to send us some planning and make an appointment for an interview. So right now it's going better and we have received something, but we still have to make it into an Excel sheet because for now it's not in this format to put it into the mitigation controller, but we can make it so that it can be
okay, that's fine. That's fine, because of course there's no like import or export function for the mitigation controller. But and again, it is not necessary for the course to put in an activity of 800 activities of the whole project. That's not them, because how many activities do you have in your example, Omar?
37 activities, and the end activity, of course, 37.
So, and that is in for the course already quite a detailed schedule, I would say. If you have like a less big network planning, given all the situations with Corona and all the stuff, we would be okay with that, as long as you show us that you know how to apply the software.
Okay.
And the concept. Okay.
Yes.
Okay, Omar. Then.
Okay.
Go on. Yeah.
So I want to go on. Just give me. Okay. So assume that you want to try different target duration. So you change your mind. You don't want to finish your project within this duration, but maybe another duration, or you just out of curiosity want to try different things. And let's see if the software is functioning as it is intended to do. For example, just one question for you, if you can answer. What if we optimize instead of 1,466, we optimize for 1,700? What do you expect? Do you expect like curve going like that? Or what? Maybe Ranar can answer this question, since you already asked me a question about this.
Okay, sorry, can you repeat your question again?
If you changed your target duration from 1,436, which is this one, to 1,700, so what do you expect to happen with the black curve? Because you are optimizing for this duration.
Well, I think the black line will not be there, because without executing any mitigation, the no mitigation S-curve is already capable to achieve that.
Okay, so you would expect that these the black one is going to join this line here, right? So both of them are going to overlap. But why don't we have like curve going this way?
Because it's not optimum, I would say. Right?
Because you cannot, because this is the lower bound.
Yeah.
Without mitigation measures, you can achieve this. So there's nothing lower than that. So that is the worst you can get.
Yeah.
Okay. So you cannot have the mitigation controller. You cannot have any curve here, or also you cannot have any curve here, because that's the best thing you could have, and that's the worst thing you could have. And we are getting the optimal thing, because the best thing is going to cost us money for not necessary thing. So let's try it. So 1,650, for example, that's quite good. It's not going to remove these. Just let's close the unnecessary ones. Okay, I will keep this one. Compare. So it's running another analysis. So your data is still loaded. You just change the duration, and you did another simulation, and this other simulation is going to be stored separately in another folder for you to compare later on. Okay, so this is the original. Okay, just make it small. All right, and this is a new one. So what you expected, what you predicted, Ronan, was true. Okay, maybe I don't know why it shows 1.2. This is one bug. Anyway, that's the one here, and you can see that the black one and the no mitigation one joined together. Okay, because the no mitigation one is just good for your well, what you want to optimize for. So the opposite case, if you want to optimize for 1,300, then of course you would expect this black line, the mitigation controller, to join this maximum bound here. You can also try it out. As you can see. So this kind of bugs, I would like you to report to me, yeah? So if you encounter something that's strange, even if you think that's really silly, just report it for me, because I'm not capable to capture all possible bugs, but of course, because you are doing different projects, you are giving different data, so you are going to encounter more bugs that I am. Okay, so where is it? It's here. Okay, so this is what we are optimizing for, 1,300. We are getting two curves that are overlapping, right? So we cannot do better than this. So with optimization, it's still 0% because we don't have enough mitigation measures to increase this probability. All right. So of course, if you want to optimize something in between, then you get the different curves according to what. Well, yeah. But again, if the probability that you get is not good enough, for example, this is a good example to give. Assume that your target duration is 1,400. Yeah, that's your target duration, and you run your simulation. So we should expect that the black line is gonna increase here and reach the intersection at 1,400, right? To maximize the probability at 1,400. So it should intersect here because this is the maximum possible probability. Let's see. Okay, so your mitigation controller increased here at 1,400. It maximized the probability, and this is the maximum probability. But again, if you are not happy with this probability, if this is low for you, what you can do, the only thing that you can do actually is to play with your mitigation measure. It means that you don't have enough mitigation measure, and your project is so delayed that your existing mitigation measures are not enough for you. All right, guys. I hope this makes sense for you. So I think today we went over really detailed, complete demonstration of the mitigation controller, so you can really test this case. So you will download this, the template which already has this case, so you can play with it. Yeah. So you can experiment there, and then you can start your own case, I would say. So yeah, I mean, if you have any question, it's the time you can ask me these questions. Otherwise,